Year 11, here's your 5-day. Here are the answers. So today we're going to have a look at circle mensuration. Mensuration means to measure, the act of measuring. And so we're going to have a look at the definition of a radian and how to use it to find lengths and areas of parts of circles. So I think you've done this in methods, you can measure angles in radians. So radians are just a different form of measurement to degrees, just like inches and centimetres exist in the world. And some calculations involving circles are easier when we use radians instead of degrees. Let's just quickly remind ourselves what a radian is. So if we have an arc AB and it has a length r, where r is the radius of the circle, then the angle AOB is 1 radian. So, and this isn't a correct term, but an equilateral sector, all the lengths or the sides are equal. This angle here is 1 radian. And sometimes we use a small c to denote radian. Rarely use this rad. Often they involve pi, so if there's a measurement involving pi, then it's radians, not degrees. It should be pretty obvious which one you're working in. Now, this arc length is r, and this gives us 1 radian. If I multiply both sides of my equation here by 2 pi, my arc length becomes 2 pi r, which you should recognise as the circumference of the circle, and that gives me 2 pi radians. So what that means is that there are 2 pi radians in a full turn. So 360 degrees is equal to 2 pi radians. So I can divide both sides by 2. It means that 180 degrees is pi radians, and I can divide both sides by pi to get 180 divided by pi is equal to 1 radian. And 1 degree is equal to pi over 180 radians. For our unit circle, where the radius is 1, a radian would be subtended by an arc of length 1. Okay, so sorry about that, I didn't mean to have the example pop up. So let's have a look at what we can do with this. If we take the ratio of length of arc to circumference, that's the same as the ratio of the angle at the centre to the total angle at the centre. So the fraction of the circumference represented by L here is the same as the fraction of the full turn that is represented by theta. So if I substitute in the things that I know, so L is the length of the arc, and we know that the circumference is 2 pi r, and that's equal to theta, this angle here, divided by 2 pi, which is the number of radians in a full turn. I can multiply both sides by 2 pi to get this relationship, L over r equals theta, and then I can multiply by r to get L, the length of the arc, is equal to r theta. That's really useful, so can you write that down, please? Make sure you either draw a diagram or write down that L is the length of the arc, r is the radius. So just to compare, this is what the formula is when we use degrees. You can see r theta is much nicer than theta over 360 times 2 pi r. So let's have a look. Oh, very, very important that the angle is in radians. So you might like to give yourself this little c there to remind you. So find the length of the arc of a circle that has a radius 5.2 that subtends an angle of 0.8 radians at the centre of the circle. So state the formula that we're using, L equals r theta. substitute in the values that we know. The radius is 5.2, the angle is 0.8, pop that into your calculator, and the length of the arc is 4.16 centimetres. We're told the radius is in centimetres, so we know that the length of our arc is in centimetres. Okay, pause the video while you have a go at questions 1, 2, 3a and 6. Okay, so we can also think about the area of this sector here. So let's go through this like we did with the length of the arc. The area of the sector divided by the total area of the circle is going to be the same ratio as the angle at the centre divided by the total angle. Let's substitute in what we know. So the area of the sector, which I've called x here, divided by pi r squared, the formula for the area of a circle, is equal to theta over 2 pi. Theta being our angle, 2 pi being the radians in a full circle. I multiply both sides by pi and then multiply by r squared. I can see that the area of the sector is theta r squared over 2, or we more often write it like this. So, and instead of x, can you write area of sector equals half r squared theta when theta is in radians. Okay, let's have a look at using this. So here I'm given the area is 28.9 and I'm given the angle and I need to find the value of r. So let's start by stating our formula. Then we're going to substitute in the things that we know. Then I can just rearrange, divide by 0.8, divide by a half, or multiply by 2. Oh, sorry, I've decided to simplify there first and then divide by 0.4. This is r squared. I need r, so I square root. R is a length, so I know it's the positive one, so r is 8.5. Pause the video now while you have a go at questions 7 and 9. So we can also work out the area of a segment using radians. A reminder that a segment is this shape here. A chord cuts the circle into 2 segments. We're going to be looking at the minor segment here. Hopefully you can see that we've got the area of the sector and we subtract the area of this triangle here. So the area of the sector is a half r squared theta. Area of the triangle, you'll remember, is half AB sine C. Here, my A and my B are both R. So I can substitute that and my angle being theta, so I get half R squared sine theta. So the area of the segment is the area of the sector, subtract the area of the triangle. And you'll notice that I can factorise this to get half R squared times theta minus sine theta. So let's just have a look at how we use this. Here's the sector. I've got an angle of pi over 3 at the centre. I've got a radius of 2.5. Here's my formula. I should really have capital A equals for the area equals. Substitute in the values I know and calculate. And then round right at the end. So I get 0.57 centimetres squared. We can also calculate the length of a chord. So if I have a look at this triangle here, if I cut it in half, it's an isosceles triangle, so I can drop the altitude there, and that gives me theta over 2. This length, PB, is r sine theta over 2, because sine theta is opposite over hypotenuse. This is a right angle. And so the length AB is 2r times sine theta over 2. With that, you can now answer questions 3b to 5 and 8 and 10 and 11. Make sure you mark your work and ask your teacher if you have any questions. Thank you.